Hey, welcome to this deep dive, all about Git. You sent over a bunch of resources, Git Essentials, Mastering Git, and of course the big one, Pro Git, right? So
Yeah.
we're going to unpack all that good stuff and really get into not just how to use Git, but why it's such a game changer.
Yeah, I think one of the things that is really cool about Git is it's a distributed version control system,
Yeah.
which really just changed the game in terms of how developers can work together. You know, you're no longer tied to like one central server. Everyone has a copy of the repository.
Yeah.
So much more security, so much more flexibility.
Yeah. And I was reading in ProGit, I think it was, about how that distributed model really like fueled the open source movement.
Yeah.
It's like Git and platforms like GitHub were really made for each other. They made it so much easier to contribute to projects.
Exactly. Yeah.
Yeah.
Imagine trying to manage hundreds of developers contributing to a single project using like
Oh my gosh.
an old centralized system. It would be a nightmare.
Yeah.
Git, the way it was designed, allowed these projects to scale rapidly and have people all over the world contributing.
Okay, cool. So before we get too deep into that collaborative stuff,
Yeah.
let's make sure we all have the basics.
Right.
Like what is Git at its core?
Yeah. So at its heart, it's a system that allows you to track changes to files over time. It's kind of like taking snapshots of your project at different stages,
Okay.
and each snapshot is called a commit.
Okay.
And then you build this timeline of your project, the way it's evolved. And the cool thing is you can jump back to any snapshot and you can see exactly what changed. You can even undo things if you need to,
Great.
which is extremely helpful when you're working with others or just keeping your own work organized.
Yeah, and setting up Git is pretty straightforward.
Yeah,
Yeah.
super straightforward.
Okay.
Yeah, both ProGit and Git Essentials have great guides for getting Git installed on pretty much any operating system, Linux, Mac OS, Windows, you name it.
All right. So let's say I've got Git installed. What's the first thing I need to do?
You need to introduce yourself to Git. So you want to set up your Git identity, which is basically your name and your email address.
Oh.
And that information gets attached to your commits, so everyone knows who made what changes,
Mhm.
which is particularly important for open source projects, as ProGit points out.
Yeah, yeah. Makes sense. So I've told Git who I am, what's next.
The next thing you'll probably want to do is choose your favorite text editor,
Like, okay.
because Git uses that when you're writing commit messages, which we'll get to soon.
Okay.
But Git plays well with pretty much any editor you like to use.
Gotcha. Okay. So Git's installed, my identity is set, and my trusty text editor is ready to go.
Yeah.
So now I need like a project to actually work on, right? How do I bring an existing project under Git's watchful eye?
That's where the repository comes in,
Right.
which is basically the container for all of the files in the history of your project.
Oh.
So to start tracking an existing project with Git, you would use the git in command.
Git in, the command that launches 1,000 projects, right? So what exactly is happening when I run that?
So it's like saying to Git, hey, pay attention to this folder, right?
Right. Right.
And it creates a hidden directory called .git inside your project folder, and that's where Git stores all of the magic, all the version control stuff.
Okay, so Git's now watching my every move in this project.
It is.
So what happens when I start making changes to my files?
Right. So this is where we get into the three states of a file in Git. So we have modified, staged, and committed.
Okay.
So you can think of it this way. You're fixing a bug in your main.py file. So you make your changes. Now that file is modified.
Okay.
You then use a command, git add main.py. And now that file is staged, which basically means you're telling Git, hey, this file is ready for the next snapshot.
Okay, I like that analogy. Like I'm setting the changes aside,
Exactly. Yeah.
for safekeeping.
Exactly. And then committed is when you actually make those staged changes permanent, like taking the snapshot. So it creates a permanent record of those changes in your project history.
Okay. So I've made some changes. I've saved them with git add, and now I'm ready to make them like a permanent part of the project's history. How do I do that?
That's where git commit comes in.
Okay.
So you would use git commit, and then you would use M with a message. So something like git commit mfix bug in login logic.
Gotcha.
And that creates the snapshot and adds a little message that describes what you change.
Yeah, the commit message. ProGit was really emphasizing how how important it is to write good commit messages.
It's true. Good commit messages are so valuable when you're going back and trying to understand why something was changed,
Yeah.
especially like weeks or months or even years later.
Yeah.
You're leaving breadcrumbs for your future self
Right.
or for your teammates.
Right. Okay, so I've I've modified files, I've staged them with git add, I've committed them with a nice clear commit message. Um, Now what? How do I look back at the history of my project?
That's where Git log comes in handy,
Okay.
which is like your project's time machine.
Okay.
And it will just show you a list of all the commits that have been made, who made them, when they were made, and of course, those all-important commit messages.
Okay. Now, Mastering Git talked about some cool ways to customize the output of git log
Yeah,
with different options.
absolutely. Yeah, so there are a lot of different things you can do. Let's say you fixed a really critical bug like 2 weeks ago,
Yeah.
and you want to see what's changed since then. You can use git log since 2.weeks to basically see all the changes since that point in time. And that way you can make sure that you haven't accidentally reintroduced any old problems.
Oh, that's super helpful, yeah.
Yeah.
I can see how that would be useful for tracking down like the source of a regression or understanding like the impact of a specific change. But what if I want to see like the actual changes made in a commit, not just the commit message?
Yeah, for that, you would use git log nofp,
Yeah.
and that nofp option will show you the diff, so the differences between the previous commit and the one that you're looking at, so you can really understand exactly what was changed and why.
Wow, that's really powerful stuff. And I think Mastering Git also mentioned things like filtering by time and
Yeah.
searching by author or keywords.
Yeah, so if you're trying to find commits by a specific developer or commits that mention a certain feature, git log has options for that as well. So author and grep are your friends there. So let's say you want to find all the commits related to the user authentication feature.
Okay.
You could use git log grep authentication to narrow down your search.
This is awesome. So I've got like the basics down. Installing Git, configuring it, initializing a repository, that whole modify stage commit workflow, and even viewing and filtering the history. But what happens when I'm working on like a bigger feature and I don't want to clutter up the main project history with a bunch of little commits?
That's where branching comes in.
Oh yeah.
Which is one of the coolest and most powerful features of Git.
Right, branching.
But that deserves its own deep dive.
Yeah, that's a big topic. We've covered a lot of ground already. Let's take a pause here.
Okay.
And we'll pick up with branching and merging in part 2.
So branching, it's kind of like having alternate realities
Okay.
for your code base where you can experiment and not be afraid of breaking anything,
Okay.
So you can try out new features, you can fix bugs, or refactor your code without affecting the main project until you're ready.
Right, right. So that's super useful when you're working on like a bigger feature or something like that. But I'm still a little bit hazy on what a branch is in Git, like technically.
Yeah.
Is it like a copy of the entire project?
Not quite. So Mastering Git does a good job of explaining this, but technically a branch is just a lightweight pointer to a specific commit.
Okay.
It's more like a label or a bookmark
Gotcha.
that you can move around in your project's history.
So it's not duplicating all the files when I create a new branch.
Exactly, yeah.
Right.
That's one of the things that makes branching so powerful and fast in Git is you're not making huge copies every time you create a branch.
That's really clever. So how do I create these magical pointers, these branches?
It's really simple. You just use the git branch command. So if you wanted to create a branch new feature, you would just type git branch new feature.
Okay, so just like that, I have a new branch.
Almost, yeah. So creating a branch is like building a new road, but you're still standing on the old one, right? You need to switch to it
Okay.
in order to start working on the new branch.
Okay, so how do I do that? How do I hop over onto my newly created branch?
That's where git checkout comes in.
Okay.
So you would use git checkout new feature to tell Git, okay, I want to start working on this branch now.
Okay, so Git checkout is my vehicle for moving between branches.
You got it. Yeah. Speaking of visualizing things, ProGit has some really good diagrams that show how branches kind of diverge and merge.
Yeah.
So seeing it visually can really make it click.
Right, right. Now, Mastering Git kept mentioning the head pointer.
Oh, yeah.
And I'll admit, it sounded a bit mysterious. What's the deal with head?
Yeah, so think of head as a special pointer.
Okay.
That's always indicating the branch you're currently working on. It's like this big arrow that says you are here.
Okay.
So when you create a new branch and you check it out with git checkout, that head pointer moves to that new branch.
Okay, that makes a lot more sense. So I've created a new branch.
Uh-huh.
I've switched to it using Git checkout. I've made some awesome changes, and I've committed them. Um, Now, how do I bring those changes back into the main project?
That's where git merge comes into play. It's the command that brings two branches back together.
Okay.
Like.
So let's say I want to merge my new feature branch back into the main branch. How would that look?
So first, you would switch back to the main branch. So you would do git checkout main,
Okay.
and then you would run git merge new feature.
And Git just figures out how to blend everything together.
Yeah, most of the time, yeah. Git's really good at figuring out how to combine the changes from
Yeah.
different branches, but sometimes you run into conflicts.
Conflicts like when two developers edit the same lines of code or something like that.
Exactly, yeah.
Mhm.
So when that happens, that's where Git needs a little help from a human. So it will flag those areas, and you'll have to decide which changes to keep and which changes to discard.
Okay, that sounds a little scary, but I'm guessing pro Git and mastering Git
Hey,
have some guidance on how to handle those.
Oh yeah, they have very specific like step-by-step instructions. It's not as intimidating as it might sound.
Okay.
Git gives you all the tools you need to make the right decision and keep your project healthy.
Okay, good. That's reassuring. And mastering Git also mentions something called a fast forward merge. What are those all about?
Yeah, so a fast-forward merge happens when the branch you're merging into hasn't had any new commits
Okay.
since you branched off. So in that case, Git can just move the branch pointer forward, kind of like fast-forwarding a video, without creating a separate merge commit.
Okay, so that's more efficient.
Much more efficient.
Okay, so far we've been talking about working like locally on my own computer, but what about when I want to collaborate with others on a project?
Right.
That's where remote repositories come in, right?
Yes. Now things are getting really interesting. So a remote repository is basically a Git repository
Right.
that lives on a server somewhere, right?
Okay.
So like GitHub or GitLab or Bitbucket, and it acts as a central hub for your project where everyone can share their changes and grab the latest versions.
So to start collaborating, I need to like link my local repository
Yes,
to a remote one?
precisely, yeah. And the command git clone is your friend here.
Okay.
So git clone will create a local copy of a remote repository. So for example, let's say you want to contribute to a project on GitHub,
Right.
you would use git clone and then the URL of that repository.
So that downloads like the entire project history to my computer.
Exactly.
All the commits, branches, everything.
You got it. A complete copy ready for you to start working on.
Oh, that's fantastic. Okay, so I've cloned the repository. I've made some changes. I've committed them locally. How do I share my work with my teammates?
That's where git push comes in,
Okay.
which is the command that you use to send your local commits up to the remote repository.
So Git push is how my changes become part of the shared project.
Exactly, yeah. Your
Right.
way of contributing to the collaborative code base.
Okay, cool. I've pushed my changes. But what if someone else has also been working on the project and they've pushed their own changes? How do get those updates?
That's where git fetch and git pull come in.
Okay.
So think of git fetch as taking a peek at what's happening on the remote repository without actually merging those changes in.
Okay.
So it will download the changes, but you can see what's new.
So it's like getting a preview of what's changed.
Exactly, yeah. And then git pull combines git fetch and git merge.
Okay.
So it will download the changes and then attempt to merge them into your current branch.
So Git pull is like hitting that refresh button to kind of get all the latest updates.
That's a great way to put it, yeah. And that back and forth of pushing and pulling is really at the heart of collaborative development with Git.
Okay. Wow, this is all starting to come together now. We've gone from like the basics to cloning remote repositories, pushing changes, pulling changes, all the essential stuff
Yeah.
for working with others. But what about those advanced Git techniques you were talking about? Things like rebasing.
Yeah, so rebasing is a really powerful tool, but it can be a bit more complex than merging. It's really about rewriting history.
Okay.
So it's important to understand like the implications and use it carefully.
Okay, I'm definitely intrigued. Let's delve into those advanced techniques and rebasing in part 3.
Okay.
This is getting good. All right. So rebasing, you mentioned that it's a bit more complex than merging.
Yeah, rebasing can be powerful, but it's all about rewriting history,
Okay.
which can be a good thing or a bad thing depending on how you use it.
Okay, so how's it different from merging?
So with merging, you're basically creating a new commit that combines the changes from two branches, right? It's like saying, hey, here's where these branches diverged and now they're back together. But with rebasing, you're taking the commits from one branch and replaying them on top of another branch as if they had always been there.
So it's like taking a detour and then seamlessly merging back onto the main road,
Yeah.
making it look like you never left.
That's a great analogy, yeah. And mastering Git makes a strong argument for how rebasing can lead to a much cleaner, like linear commit history,
Okay.
which can be really helpful when you're working on a team or you're just trying to understand the evolution of a complex project.
Yeah, yeah. Cleaner history sounds great. But you also mentioned some risks with rebasing. Like
Yeah.
what should I watch out for?
The golden rule of rebasing: never rebase commits that you've already shared with others.
Yep.
Like if you've pushed them to a remote repository.
So rewriting my own, like local history is fine, but
Yeah.
once those commits are out in the shared project, things get a bit dicey.
Exactly, yeah. Rebasing shared commits can create a lot of confusion and conflicts for your collaborators. ProGit has a really good section on this,
Okay.
with some clear examples of how things can go wrong if you're not careful.
Okay, so rebasing. Use it wisely and only on local commits.
Yes.
Got it. Um, what about this interactive rebasing that Mastering Git mentioned?
Ah, yes. So interactive rebasing, which you start with Git rebase,
Okay.
gives you fine-grained control over your project's history. So imagine you've been working on a feature
Mm-hmm.
and you have a bunch of experimental commits and things are a bit messy.
Right.
Interactive rebasing allows you to clean things up before you merge into the main branch. So you can squash multiple commits into one, you can edit commit messages, you can even reorder commits.
So it's like having an editor for my commit history.
Exactly, yeah. And it's especially useful when you're getting ready to share your work with others. You can use interactive rebasing to really polish those commits, make them nice and concise and well organized and telling a clear story.
Yeah. Okay, rebasing and interactive rebasing, Jack.
Yeah.
Now, what about stashing? I've seen that git stash command, but I'm not really sure what it does.
So think of stashing as a temporary shelf where you can put your uncommitted changes.
Okay.
Right? So let's say you're in the middle of working on a feature, but you need to switch gears quickly to fix a bug on another branch.
Right. I've totally been there.
And you don't want to commit your half-finished work, but you also don't want to lose your changes.
Right. So stashing lets me save those changes without committing.
Exactly. You would use git stash to kind of tuck those changes away safely,
Okay.
and then git stash apply to bring them back when you're ready to continue working on them. Mastering Git has a nice little visual explanation of this, actually.
Okay. That's really handy. Mastering Git also mentioned this thing called the reflog. What's that all about?
The reflog. So the reflog is Git's safety net.
Mm.
It keeps a detailed log of every change that you've made in your repository, even things like deleting branches or messing up a rebase.
Wow, so it's like a super undo button.
Yeah, pretty much.
Even for actions that seem
You
permanent.
got it. You can use Git reflog to find the ID of a lost commit
Wow.
and then Git checkout to recover it. It's saved me from a few oh no moments for sure.
But the reflog sounds like a must-know for any Git user.
Yeah.
We've covered rebasing, interactive rebasing, stashing, the reflog, a lot of powerful tools here.
Yeah.
What about those Git hosting services like GitHub and GitLab?
Yeah.
What role do they play in all of this?
Yeah, so services like GitHub, GitLab, and Bitbucket, they've become essential for collaboration.
Right.
They provide a central platform to host your remote repositories, making it easy to share code, track issues, and manage projects with your team.
Yeah, and ProGit talked about how these platforms were instrumental in the rise of open source software, right?
Absolutely, yeah. The ability to easily fork projects, contribute changes, and participate in discussions has made open source more accessible than ever.
Yeah, that's amazing. And Mastering Git even gave us a little peek under the hood at Git's internals.
It did, yeah. It explains how Git stores data as a content-addressed file system using objects like blobs, trees, commits, and tags. And understanding those internals can be really helpful for troubleshooting, or if you just want to, dive deeper into Git's inner workings.
Yeah.
But even without going too deep, you've got a solid grasp of the core concepts, and that's what matters most.
This is a fantastic deep dive into Git. I mean, we've covered so much ground, from the basics to those really powerful advanced techniques, I feel like I've gained a much deeper understanding of how Git works and how to use it effectively.
I think the key takeaway is that Git gives you incredible power and flexibility as a developer, right? Whether you're working solo or as part of a team, Git provides the tools you need to manage your code, track changes, experiment freely, and collaborate effectively.
Yeah, and the stories in ProGit about how Git has shaped the world of open source development are really inspiring.
Yeah.
It's just amazing to see how one tool has had such a profound impact on software development as a whole.
Absolutely, yeah. And as you continue your journey with Git, remember that practice and experimentation are key. Don't be afraid to try things out, explore the documentation, and see what works best for you and your team. And don't forget about the reflog.
Yeah,
It's there to save you if you make a mistake.
that's great advice. And I think mastering Git briefly touched on different Git workflows. Maybe
Yeah.
maybe that's something you could explore further. Experimenting with different branching strategies and collaboration models can really help you find what works best for your specific projects and team dynamics.
Exactly, yeah.
Yeah.
Git's incredibly versatile. There's no one right way to use it. It's all about finding what fits your needs and helps you and your team work more effectively.
Well, this deep dive has been incredibly helpful. Thanks so much for breaking it all down for me.
It's been a pleasure. It's been great diving deep into Git with you. Keep learning, keep experimenting, and you'll become a Git master in no time.
I will. And if I have any questions or discover anything interesting along the way, I'll be sure to share it. Happy getting.